This will be a short presentation on how to interpret correlation outputs, tables, as well as how to use the TI-84 calculator to compute and interpret the correlation statistic. This first example is a correlation output from SPSS. And what you'll see here across the top are 5 variables, which are the same variables across the left. With those is the Trauma Impact of Event Severity Score, Trauma Healthcare Productivity Survey Score, then 2 Workplace Violence Scores, and then the age value. Now I'm going to switch over to show you more specific about how it would look when it comes out, if I can get to it. So this screen here now shows you what the output may look when it's coming out of SPSS. So for here, what we would find out is that this correlation, Pearson correlation statistic, has a value of 1. And as you'll remember, the values for correlation can be as low as -1 for a strong negative correlation, to 0, which is no correlation, and then going up to number 1 for a strong positive correlation. And on this one, it does not show a significance, and the reason why is that right now we're correlating trauma IES score to trauma IES score. And so if you put each number in one row side to the other, since they're identical numbers, since they're identical data set, you should then have a strong positive correlation. So this right here, you'll notice all the way down the diagonal that these values are all 1 because they're all being evaluated against each other. And if you also look at this cell where it says trauma HPS score being compared to trauma IES score, you'll see 0.026, and you'll notice that on the opposite side of this midline that we now have another 0.026. And the reason for that is that's just the opposite. Now it's trauma HPS to trauma IES. So when you're looking at this at a data table, you really only need to look at either the bottom half of the data or the top half of the data, because again, those are mirror images of each other. And you'll see here that this has a very weak correlation of 0.026. Not surprisingly, it is not significant at 0.691. This correlation of workplace violence IES with trauma IES has a moderate to strong, approaching strong correlation, is still moderate at 0.658. And you'll see that this one is also significant at a p of less than 0.001. And on this, it only shows 3 values, so we really can't say what that 4th value is or the following values are. What we can also show, though, is here it does have 2 asterisks. Those 2 asterisks let you know that there's a legend at the bottom. And on this particular one, it says the correlation is significant at the 0.01 level for a 2-tailed test. And as you know, it's definitely stronger than that for the significance, but at this time, that's what the data table is showing us. And if so, looking at this, what I can say is that as the workplace violence IES scores up, there's a very approaching a strong correlation or comparable increase in trauma IES. And again, we don't know which causes the other, because again, if we look at just the opposite, workplace violence going with, let's see where we're going. So on this side, workplace violence going with trauma IES, we can't say that now trauma IES causes workplace violence IES. It has the same value, but we don't know which came first in terms of the chicken caused the egg or the egg caused the chicken. And we'll also now look over at this value of workplace violence HPS score with workplace violence IES score. Here we now show a negative value, a negative 0.122, showing a weak negative correlation between those 2 variables. Now back on our PowerPoint, this is an excerpt from a manuscript that was written by Gates, Gillespie, and Suckup. It had the same data set that I just showed in the previous slides. And here it's looking at scales on the impact of event severity score, which are those avoidance, intrusion, hyperarousal. Going across the top are then subscales of the Healthcare Productivity Survey, an instrument that we developed about a year or two ago. Now I'm going to pull from the article itself. Oh, sorry about that. And so here you would now see that in the manuscript itself, this is how you may see a data table presented in terms of correlations. On this one, it shows that under this first row of cognitive demands to all the subscales in the first column, that they're all negative correlations and they're also highly significant. And you'll see that most all of these are all negative correlations, meaning here that as the cognitive demands of the work goes up, nurses demonstrate a decreased avoidance intrusion. So as they're able to think better, they actually have less avoidance. As the demands of their work go up, they then have less avoidance and such. But when you get down to safe, compassionate care, that when you have these two values in terms of avoidance, intrusion, hyperarousal, that really as some of these values go up, the safe care also goes up. And so you have to go back and then make an interpretation. So how can, if the demands for your safe, compassionate care goes up, how can your avoidance also go up? So you have to look back then and try to explain some of those values in terms of the clinical significance of what that means. Of course, in this instance, there is no statistical significance, but does that have any bearing on clinical significance, which that'll be something for a separate discussion. I'm going to flip back to the PowerPoint again. I'm going to talk about the steps for using the calculator to compute a correlation. For your homework, I do not expect anyone to be doing that by hand. If you are, you will spend an incredible amount of time. And as you'll see walking through these steps, you can do it in as short as 1 minute. So in your calculator, create a list and go ahead and follow along with me, and I will do the same. So first you need to power on your calculator, get to the screen which has your list, and then for list 1, you'll put in your X data. So here we have 5, enter, 1, enter, 3, enter, 4, enter, 2, enter. Now we need to scroll to our next list. So here you can put in L2, put in your Y data. Here you put down not the minus sign, the subtraction sign, but here you want to use the negative key, which is right next to the 0, and then the decimal point, and the next one is for a negative value. So push -2 and enter, 3 and enter, -2 and enter, 6 enter, 7 enter. Now we have our data set. So I'm going to turn back off my calculator and then turn it back on. Now across it, I'm going to now push stat on my keypad, scroll over to test, push enter. Oh, sorry. Scroll over to test and then actually scroll down until you get to option F, which reads a linear regression t-test. So I'm going to now push enter. And now you see on the screen, X list, you want to put in your list. For your Y list, put in that as well. So most likely we would have done L1 and L2. Frequency is the default of 1. Now in terms of our beta and our row, we're going to choose the not equal to 0. Leave the next one cell blank, and then push calculate. And on your calculator screen, you should now be showing these particular values, or actually these on your row, and it'll even show you the formula that Y equals A plus BX. It will give you the t statistic for this calculation correlation. It will give you the significance value or p-value, your degrees of freedom, your A value, your B value, standard deviation, or I'm sorry, your S. Then it will give you your R squared as well as your R. So based on this, I can say that 16.5% of this deviation within the sample is all attributed to the variables that we were computing. So if you want to now try to graph that out, so that say if you're doing the homework and you want to get an idea without having to try to enlarge the homework screen to see what the screen looks like, you can get a quick representation in terms of what the graph should look like approximately. Here you push your second key, and then directly above the second key is a YE, push that, and that activates the stat plot. And now you'll have on your screen 4 options. Make sure that options 2, 3, and 4, at the end of those plot lines it says off. Otherwise, you need to turn those off. Now we're back at 1, which should say plot 1 on, so we're going to push enter. And now it shows the flashing cursor over the word on. Make sure that you leave it as on. Scroll down to type. There's 2 rows. You want to choose one on the top left, which kind of looks like a mountain, but it's basically for your scatter plot. Scroll down for your X list, put in L1. Your Y list, put in L2. And in terms of your mark, if you want a circle, a plus sign, or a dot, that's up to you. So go ahead and keep that. And now directly up on that top row again, up by the calculator screen, there's some gray keys, at least on mine they're gray. You want to push the zoom, Z-O-O-M. And then scroll down to option 9, which says zoom stat, and then push enter. And now what you should have is 2 data points below the line or the horizon, and then 3 data points above that. And then if you go back to the homework screen and you had that as a question, you would find the one that looks most approximately to that. And again, depending on the scale, the values may look a little bit distorted on how you're doing that. Okay, if you have any further questions, just please post those to the Blackboard discussion. Thank you.